is super good to see you. We have a question of the day up on the board for you today. It says, what are some examples of slow and fast weatherings? If we are going to be taking notes today, Lexi, put your phone away. If we are taking notes today, my bad, I'm sorry, that's my fault. I need you to get those notes out because we are going to need those notes in order to answer today's question. So get your notes out from yesterday. Take that out of your ear. Get your notes out from yesterday. While we're waiting for some people to take their notes out, we're going to have a little, I've been taking like a little straw poll. How many of you think there's not going to be school tomorrow? How many of you think yes, there'll be school tomorrow? Or how many of you think it'll just be a delay tomorrow?
Delay.
So I want to go ahead and, first of all, hands in the air if you think there'll just be a 2-hour delay.
I'm hoping so.
Nobody is.
No, just cancel it.
Right. So I've got 4 people that hope or think there'll be a delay.
Non-existent here.
How many of you think that there will be school tomorrow? I'm not saying what you wish. How many of you think that there'll be school tomorrow? Okay. How many of you think that they'll cancel school tomorrow? 1, 2, 3, 4, 5, 6, 7. You can't vote twice.
All right, take me out that one.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you said take you out of the delay, and nobody thinks that there will be school tomorrow. I don't know. I mean, I'm thinking that we'll probably have school because we all don't want school, and so I just think that that's the way it's going to happen. But if you look at the radar, what's the radar saying?
That it's going to snow.
Radar saying that we're going to have a lot of snow, maybe up to 6 or 7 inches of snow, so we'll see.
I gotta wear my Timbs.
All right. Hassan, get your stuff on, man. Billy, you didn't get to vote. Do you think yes, there'll be school tomorrow, no, there'll be school tomorrow, or we'll have a delay tomorrow? I'm asking you just to pick, man. What do you think?
You should make a call and just say, I don't know.
No school tomorrow. We'll see. All right, so the question of the day says, what are examples of slow and fast weathering? I'm going to be quiet. I'm going to ask you to try to be quiet for 1 minute while we are having you get your notes out and think about this. That'll give me a time to take attendance. Ready, set, go.
Yep, there she is.
Just Mark Johnson. Girls. All right, let's go ahead and see how much time we have. We got 8, 7, 6, 5, 4, 3, 2, 1, and we are done. Please turn with the person next to you, as some of you already are, and go ahead and share out, please. Give me an example of slow and fast weathering. Ready, set, go.
5, 8,
You'll have to, or you can have to share with me.
6, 5, 4, 3, 1.
What's up, Ray?
And we are done. All right, give me an example of slow weathering.
Temperature change.
Okay, yeah, temperature change. Temperature change is a great example. Would you mind switching that over this way, please? So slow, a good example would be temperature change. If a rock gets cold at night, then what does it do? Contract or expand?
Expand.
It contracts. I was thinking water, sorry, that's all backwards. So it will contract, and then if it gets hot during the day, that rock will then expand. And so this constant expanding, contracting, what happens is you get lamination. And what happens then is you get rock that kind of pops out. And I want to show you an example of that happening in real life. Let's see if we can see that happening. Rock lamination due to temp change. Let's see if we can find something happening with that. Weathering of rocks, blah, blah, blah. How does temperature affect rocks? Rocks break. What's it called? What is it called? Physical weathering. Yes. But it's called something. Let's see. What is that called? Overburden, overlord, something like that. I can't think about what it's called. We'll figure it out later. For now, though, let's go ahead and look at a fast change. What's a fast change?
Earthquakes.
Yeah, good one. So we've got earthquakes. And yesterday, did we look at those videos at Turkey and Syria?
Yeah.
Gosh, so sad. And so you can move a lot of material at once. This is called mass wasting. So a lot of material is eroded and then moved. So it's kind of like a weathering erosion sort of thing all at once. Terribly, terribly sad. Volcanoes, another example of mass wasting. A lot of material just gets torn down and moved at once. Did you write anything down, bud? Jane pencil. All right, let's go ahead then. We have a quiz tomorrow, as somebody reminded us, so thank you very much. If we don't have school, what do you want from me, man? You're in high school. If you don't have school tomorrow, we're going to move that quiz till Monday. So please just know, if there's no school tomorrow, we're going to have quiz on Monday. My recommendation for me, just to prepare myself, I'm bringing home my computer and all of my materials so that I can work over the weekend. My recommendation is don't just leave all of your stuff at school tonight, because you may not be coming to school tomorrow. Let's get our notes out, please, and finish up that. I'm going to turn the front lights off. Last we were together, we finished talking about chemical weathering.
What is that? Feldspar?
Yeah, feldspar. Did I show you feldspar? I think I did. That pink rock. Okay. So then the E, what's the E stand for?
Erosion.
Right, so let's do it. Where's your stuff, man? Carry all that stuff around. Might as well use it. All right, E for erosion. Come on, little pen. Fine, everything's fine. Everything's great. Erosion. Can someone please tell me what's erosion? What? Yeah, that's exactly what it is. Let's write that down. Moving sediments. All right, now, there are several ways that sediments can be moved. We are going to be talking about the three main ways. The first one is water. Anytime, well, our rivers in Iowa, they're not supposed to be brown, y'all. Why are they brown?
They're brown.
Rivers in Iowa? Have you seen a river in Iowa?
Oh, come on, Pearlhead. Pearlhead.
They're brown because they're moving an awful lot of sediment. There's lots of sediment in suspension. That was not nice. And then the next thing is wind. Wind can also move a lot. And there's something that we need to know about this. So, if the sediment, now how about this? If the water or wind has less energy in it, so let's go ahead and start with that one. So if there is less energy, and I'm just going to make E with a circle, because that's my symbol for energy, or there is smaller massed sediment. So I'm going to say less mass sediment. Do you need another paper, bud? We gotta get you a better organization system. Let me get you another piece of paper. William, gotta be ready to step down, okay? And this, you wanna keep it, please take it away. Alright, so if there is a smaller bit of sediment because it's got less mass, or there's less energy in the system, what you're gonna have, oh damn it, this is not supposed to be less, this is supposed to be more. I'm sorry, can you erase this and put more? This writing is so unprofessional. If you have a pen, I apologize. Ouch, I got shocked. That is supposed to actually be more, not less.
Both of them?
Nope, just that one, honey. If there is more energy in a river, or more energy in the wind, or less massive sediment, you are then going to have a further movement of the sediment. So, farther sediment movement. Sorry about that, y'all. And by that, I mean that if the sediment is kind of like in a very slow moving river, or if the sediment is in a very fast moving river, the sediment is going to move much farther in that river that has more energy. Or if you have small little particles or large particles, the smaller particles are going to move farther and be carried farther than the larger particles. And I want to do a little demonstration with this bunch of sand. So we've got sand in here, and I don't know if you can see it, but some of these pieces are larger particles of sand and some of them are smaller particles of sand. And so I'm going to put this here, and I'm going to use a hair dryer, and we're going to see what kind of particles we get that come out. I'm going to start with not more energy, but less energy. So I'm going to have this on low, and I don't see a lot of particles flying around. Now, if I turn this up to more energy, we are getting some movement of the larger particles in here, but what do we also notice that's happening around the table? The table is getting covered with lots of tiny little particles. It is the smallest particles that are being carried the furthest. There's some big pieces in here, but they're not leaving the tray. They're just staying in the tray. And we've got lots of material now that has got on the desk. So that's kind of what that is. That's what that means. And so I just kind of wanted to show you that. Plus, I want to show you something else that I think is kind of cool, but I don't know what happened to my ping pong, so I can't show you that. Ping pong ball? Anybody see a ping pong ball on the floor? We'll look for that later. Dang it. Alright, so now another way that we can move lots of sediment is with ice. And we do that in the form of a glacier. Remember what we said, glaciers are just rivers of ice. We said that over in this area right here. Glaciers are rivers of ice. And this is how glaciers can change the land. When the temperature on the planet lowers, which means the temperature on the planet is colder, then what happens is in the mountains, glaciers advance. When I say they advance, that means that they are growing faster than they are melting at the front. So they always grow where it's really cold, and they press down and push the glacier forward. When this happens and they're growing out, they pick up sediments and large boulders. We should not have big, what's called glacial erratics made out of granite. We should not have any granite boulders in Iowa because our bedrock is limestone. And yet, if you are traveling around the countryside, you will see big boulders the size of a bus, like in farm fields. And that's because those big boulders of granite have been carried by glaciers and deposited here. A glacier kind of acts like this. If I have a whole bunch of stuff piled up in front of this, and I am pushing the glacier in this direction, the glacier slowly, because it's advancing, and we've got lots of snow coming down, and it's pushing the front of the glacier out, and as it's advancing, it's pushing and piling up all of the stuff in the front, just like a big plow or a bulldozer. Then, when it warms up, the glacier does what's called retreat, which means that it's melting at the front faster than the snow is falling at the back. And so the glacier slowly starts to look like it's going backwards, but it's just the front is melting. And we get all of this piled up debris at the front. Has anybody ever heard of Long Island? Long Island is the end result of a glacier. It's just a big pile up left behind after the glaciers melted. So let's go ahead and write that down. We've got when temperature warms, the planet gets hotter, and glaciers retreat. And they don't actually go backwards. They just melt, the front of them melt, and so they are shrinking. They shrink. When this happens, they leave sediment behind. Did you get to go to Long Island, Hassan, when you went out to? No. Has anyone ever been to Long Island? Long Island is what's called a glacier moraine. I'd love to show you a picture of it, so by God, I'm gonna. A moraine is like a really big pile up of sediment. So let's go ahead and say Long Island Glacier. Long Island's geology, no, I don't want a video, I just want to see images. Okay, so this is Long Island right here, and what happened was, maybe there's a better picture, we can have more. Okay, so this is Long Island right here, and the glaciers came all the way down and pushed the sediment, and then the glaciers started to retreat, and they left behind this big pile of sediment that now we call Long Island. This used to all just be pushed sediment from a glacier that was coming in this direction. A lot of people don't know that, but that's what it is. All right, big deal, Miss McGrain, nobody cares. Let's go ahead and look at the last one, which is D. D stands for what?
Deposition.
Deposition, let's write it down.
Stands for no.
Nope. And deposition means dropping sediments off in a new location. In this case, we are not tearing anything down, we are actually building new rock. So we build new material or rock or land or whatever the heck it is that you want to say. But we're not tearing anything down at this point, we're building new stuff up. So during deposition, we say sediment is resting at a semi-permanent location. Why is it semi-permanent? Will, why is it semi-permanent?
Because it can still be moved.
Absolutely, and it's going to. So let's go ahead and write that down. Sediment is resting at a semi-permanent location. Now, during deposition, these are the things that are made. Like you took down a mountain during our relay race and you made a beach. So beaches are created through deposition. Iowa has many, many gravel pits that were created during deposition. So our gravel pits that we have so much of and that are so economically suitable are due to all of the glacial stuff we've had going on. Deltas, has anybody ever heard of a delta at the mouth of a river?
Yeah.
So when energy slows down, you have sediment dropping out. So if we have less energy in a river, as you go to the opening of a river, you're gonna have less energy and you're gonna have that sediment dropping out. You're gonna make these beautiful deltas, dang it, these beautiful deltas that form at the mouth of rivers. So deltas, mouth of rivers, that's made by deposition. And then, as I said earlier, glacier or glacial, what's called moraines. That's what's being pushed and left behind by the glacier. So we can say left behind sediments. Are you thinking, honey? Because you're upset, or just because you have an appointment or something? Okay. After this happens, oh, honey, you have homework tonight. Do you think you might come back? We have an ed puzzle on Canvas. Okay. After this happens, one of two things happens to make a sedimentary rock. What's one of them? Cementation, and the other one? Compaction. So let's go ahead and write down compaction first. Compaction is the easy one. What happens during compaction? If something's compacted, yeah, squished, oops, or squeezed together. That's an N. So I'm going to say squeezed together or cementation. And you all made a great rock out of this. We have minerals carried by water. I'm going to say carried by H2O. And left behind. Left behind between sediments. Yep. We're going to do a little check for understanding. It's not a quiz or anything, but it is a, I'm going to show you some pictures and leave this out in front of you because you're going to tell me which was, what is that, honey? That's a beautiful rock. Now, because it's so rounded, what do you think it has been formed by? I would think maybe abrasion. The wear down by rubbing. That's gorgeous. Are you giving this to me? Yeah. Yes.
I don't know what type of rock it is.
It looks like, I don't think it's calcite, but it looks like quartz. Quartz is actually a mineral. It's actually a crystal. And it is very, 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 very hard. And a lot of times, quartz is found in conjunction with gold. Quartz? No. You can find quartz anywhere and everywhere.
My sister found a geode once, but then she lost it.
Oh. All right. We are going to look here. I've got some videos that I want to show you. So let's go ahead and do this. Can someone get up and shut those lights off, please? Oh my God.
You're right there, probably.
Dang it, I keep getting shocked.
Why?
All right, we're going to go ahead and watch a little video. And I want you to tell me if this is slow or fast weathering. It's very cool. And you can see that the larger stones are not really moving as far or fast as the smaller ones. They're just kind of like cruising. These larger ones aren't even moving at all. And so what you've got is this is how sediment moves in a river.
Wouldn't that be erosion, not weathering?
It is, it's weathering, yeah, it's being broken down, but then it's also moving. They're kind of working in tandem. Slow or fast? It's actually slow. It looks fast, but if we're talking about changes to the land, this land is going to be happening in a slow process over a long time. It's going to take a long time to move this material. You know the Mississippi River?
Yeah.
The path of the Mississippi River today is not the path of the Mississippi River that has always been there. You got to see this. I discovered this and I thought it was the coolest thing, like old paths of Mississippi. Is it Mississippi River? So the Mississippi River, if we can look at like this picture, you can see that the Mississippi River has changed its course over many thousands of years. So we can tell by looking at satellite images. Can I get this bigger? No. Through satellite images, you can see that the Mississippi River, this is the current Mississippi River, but these are old channels of the Mississippi River, and it has moved a lot in that river basin. Isn't that crazy? But guess what? It doesn't do that anymore because human beings don't want it to move. Because what have we created along the edge of this river now? Houses, cities, right? Like Davenport. And so we don't want the river to move all the way over here, right? This is like old ancient pathways. And now human beings spend billions of dollars trying to keep the river where it is right now. But it hasn't always been that way. Rivers move over time as the sides get eroded away. Gosh!
Stop getting surprised.
I am not trying to shock myself. It's just kind of happening. Yes, absolutely. All right, let's look at this next one. This is Mount St. Helens.
It's fast.
This is actually slow motion, but Asa's already saying, hey, I think that in terms of weathering and erosion, that he's saying this is a fast event.
Just a lot of people died.
Yeah, about 15 people died. But we knew it was happening, so a lot of people were able to. All right, so if we look at this, then this is the mountain May 17th, 1980, and then this is what happened after the eruption. So what do we notice that's different?
It's like a bowl shape.
Yeah, so the top of the mountain's gone. We got kind of like a little caldera kind of shape here. What do we notice about the forest? It's been covered by what? Ash and lava flow and pyroclastic flow. And so this was a very fast event because it happened like all in one day. All right, let's go ahead and look at this. This is what's called a landslide.
It looks like it's liquid, but it isn't.
And so in this case, fast or slow? It's a very fast event, something that has happened all at once.
Liquefaction.
Liquefaction. Yeah, oops, I guess that was the end of it. All right, so then now what we've got, my dears, is we've got a ED puzzle. If you could please make sure that you get your computers out. If you need headphones or AirPods, do that. I want to let you know that there is a link for you right here. So you're going to go to Canvas, click on this link, and you're going to do the ED puzzle. Alex, get off your phone, sweetheart. Do you want the lights still low? I know, it's really hard though to be sleepy. You want me to just turn the back lights on low?
No.
Well, Hassan's definitely a no on that. You're a no also? 100%. Could you please not be in there for the rest of the period?